Hello, can you solve for a plus b in 1 divided by a plus 1 divided by b equal to 1 divided by 7, while a and b are elements of real numbers, positive real numbers. So how can we find the values of a and b when given expression that has to do with fractional values or fractional indices or fractional values? All we need to do is to look for how we can find a breakdown or take away the fractional values. So how do we do this? The best way is to look for the least common multiple, which is a multiplied by b. So to remove the fraction, all we need to do is to multiply both sides by a multiplied by b, which is the common multiples. So we'll have a, b multiplying 1 divided by a plus 1 divided by b, and all of these will be equal to 1 divided by 7 multiplied by a. Now remember, whatever you do to the left hand side, you always do to the right hand side. So if we simplify this, AB will multiply AB multiply 1 divided by A plus AB multiply 1 divided by B, and this will be equal to AB divided by 7. So what do we do over here? A cancel out A, while B cancel out B. So we'll be left with B plus A equal to AB divided by 7. Great. So what do we do from here? What do we do from here to find the value of AB? Now, if we take this to become a fraction by dividing this by 1, we can simply cross multiply. And if we cross multiply, our AB will simply be equal to 7 multiplied by B minus A or plus A, and that will give me AB to be equal to 7B plus 7A. So how do we do this? To simplify this further, I'm going to collect all the term to one side. So I'll have AB A minus 7B, and this will be equal to 0. So how do I simplify this? I'll simply collect terms among these, and the very good terms is A. AB divided by A will be me B minus 7, right? And this will be minus 7B, and all of this will be equal to 0. So for us to simplify this, we need to look for a value that can make this expression factorizable. Now what I'm going to do is to simply add, since 7 multiplied by 7 will give me 45, all I'm simply going to do is to add 45 to both sides. So we'll have B minus 7 minus 7B, and this will be plus 49, not 47. 7 times 7 will give us 49, plus 49 minus 49. I didn't change anything, and this will be equal to 0. Now with that, I can easily simplify that expression. If I simplify that expression, I'm going to have my A multiplied by B minus 7, and this can always be one common term. I'll have my 7 is common, so I'll have this to become B minus 7, and this will give us negative. When we take it to the other side, I'll have it to be what? 49. So this has shown me that there are two similar expressions, b minus 7. So I will take one, and I'm going to have this expression to now give me b minus 7, right? And this will give me a minus 7, and this is equal to 49. Now, this expression can easily be simplified because I can equate both sides with whatever I'm going to get on the right hand side. Now, I have two factors, b minus 7 and a minus 7, and this can be equal to two expressions. So from this expression, I can have 49 multiplied by 1. I can have 1 multiplied by 49, and I can simply have my 7 multiplied by 7. 7 multiplied by 7 is going to give me 49. So I'll have three cases, two factors giving me giving me three cases. So I'm going to simplify these two factors and equating them to these three cases. So what do I do? Having these three cases, I'll take one case at a time. Now, if I take one case at a time, I'll be having my a, case 1, I'll be having a minus 7, which is the first, and then I'll have b minus 7, and this can be equal to, the first one is 49 multiplied by 1. So I can equate both sides with my a minus 7 equal to 49, and then I have my b minus 7 to be equal to 1. So what do? I'm going to have a to be equal to 49 plus 7. I'll have my a to be equal to, that's going to give me 50 what? 56. Now over here, I'll have my b to be equal to 1 plus 7, and then I'll have my b to be equal to 8. So that means I have my a to be equal to 56, and I have my b to be equal to 8. Now we're going to consider the second case 2. Case 2 will still give me the value of a minus 7, and then I'll have my b minus 7, and this will be equal to 1 multiplied by 49. So if 1 multiply 49, I'll have my a minus 7 to be equal to 1, and I'll have my b minus 7 to be equal to 49. So from here, I can have my a to be equal to 1 plus 7, and I'll have a to be equal to 8. While over here, I'll have my b equal to 49 plus 7, and then my b will be equal to 56. Now that's my second case. In my third case, I'm going to have 7 multiplied by 7. So I'll have my case 3, C3, to be equal to a minus 7 multiplied by b minus 7, and both to be equal to 7 multiplied by 7. So what do I have? In the first case, I'll have a minus 7 to be equal to 7, and then I'll have my a to be equal to 7 plus 7, and then my a will be equal to 14. While on this other side, I'll have my b minus 7 to be equal to 7, right? Then I'll have my b to be equal to 7 plus 7, and then my b will be equal to 14. Now, how do we find the value of a plus b? Remember, they say a plus b must be equal to positive real numbers. So a plus b from the expression where I have 56 and 8 can simply be equal to a 56 plus b is equal to 8. So a plus b will simply be equal to 64. Now case 1 and case 2 will give me what? 64. Now in case C or third case, I'm going to have my a plus b to be equal to 14 plus 14, and then a plus b will be equal to 28. So that means I have two solutions, 64 and what? 64 and 28. So that means a plus b is equal to 64, 28. And that remains the solution to this math problem given to us. If you did enjoy watching this math solution, don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.